Welcome everybody. So this is our first pit for today. I'm Alex Barry, I'm the soil management engineer for the province of Ontario, and this is my colleague Dan.
I'm a soil scientist or land resource specialist with the Ministry of Agriculture in Guelph as well. So I'm going to just start this first video off by talking a little bit about the soil profile, and I'll probably cut it off because I can talk a long time about a soil profile. But we were able to pull off a nice big chunk of the soil pit face here to expose some of the soil horizons. So first off, we're in basically a lake bottom, an ancient lake bottom. So it's fairly level topography here, and clay deposits mostly at the surface that would have been laid down when we were under probably hundreds of feet of water here about 10,000 years ago. So just to point out the soil profile, so as we know, the soil profile develops in horizons. The first surface horizon is typically, you can tell because it's rich in organic matter. And so you can really see that line kind of across here. It's about 30 centimeters thick or so, maybe a bit less here, of rich organic matter in the surface layer. We would call that an AP horizon. You can see this brownish layer that's down here, and it might be hard to see from the camera, but again, so this soil has some bright orange mottles in it, and it's pretty brownish gray in color. So this would be a B horizon. We would call this a BG horizon, and the G stands for glaying, which is this gray color, and then these prominent mottles as well as part of that process. And all that color means is that this soil profile is holding on to a lot of water for a prolonged period of time during the year. When we get down here, we get into a transition horizon. That would probably be our first C horizon, which is your parent material. So the C horizon is the parent material. And then down at the bottom here, you might not be able to see it because it's pretty fine, but these are what we would call varved clays, varved silt. So you can kind of see the layering. So that was sitting like this in the soil profile. You can see how nice and flat that is. So these layers are all deposited slowly in water. And the other thing that's interesting about the parent materials in Ontario, most of them are developed from limestone. And so we use hydrochloric acid, and it reacts with free carbonates, and so you'll just see some fizzing. So that's how we know kind of that's about how deep soil has developed in Ontario when you find the fizzing in the material down at depth. So in this case, somewhere around 75, 80 centimeters. And so this soil is known as the Atherley clay, and you can find it here, and you can also find it all the way on to Prince Edward County.
Wow.
So there you go.
So I should mention a bit about the plot. This is our first treatment here. So this was a broadcast rye, radish, and crimson clover in the fall last year, and then no-tilled into corn, obviously this spring. And what we're seeing here is good root structure, lots of fibrous roots in the profile, and fairly good structure. What we'll see and a worm. There's our first worm for the day. Basically what we're seeing here, and spoiler alert for the next pits, is very, very compacted, very massive structure. So this field has a history of somewhat tillage, maybe some no-till over the last 4 years. It's hard to get a good but generally what we do know is this site is compacted and poorly. Not compacted poorly, but poorly, you know what I mean. So we are seeing we basically took the top of this field, the first 4 inches all over the field, made it one big patio slab. Because you can just peel off layers of compacted topsoil, and as we go look at more of the treatments with fewer roots in it, you get big blocky structures in the profile. So the benefit of having all these fibrous roots growing last fall and then the corn into the spring is we've got some real good fibrous material that's breaking up some of this big packed structure. So you can see some of these roots, and everywhere I kind of peel at it, you get a root in a crack, but in small cracks. So we'll move on to the rest of the pits, and we'll sort of compare and contrast, I guess, to what we see in each one.